configure site-to-site IPsec VPNs. Welcome to the Site-to-Site VPNs module. This module explains how to configure site-to-site IPsec VPNs. The module also describes proxy IDs and traffic selectors and explains how to configure them. Finally, this module explains how to monitor site-to-site IPsec VPNs. At the end of this module, you will be able to configure site-to-site IPsec VPNs, describe proxy IDs and traffic selectors, configure proxy IDs and traffic selectors, monitor site-to-site IPsec VPNs. IPsec VPN configuration consists of 3 steps: configuration of Internet Key Exchange or IKE Phase 1, configuration of IKE Phase 2, and configuration of the required VPN routing parameters. Configuration of IKE Phase 1 includes configuring IKE Phase 1 proposals, configuring IKE Phase 1 policies, referencing the proposals, and configuring the IKE Phase 1 gateway referencing the policy. Configuration of IKE Phase 2 includes configuring IKE Phase 2 IPsec proposals, configuring IKE Phase 2 IPsec policies, referencing the proposals, and configuring the IKE Phase 2 IPsec VPN tunnel, referencing the IKE gateway and IPsec policy. Configuration of the required VPN routing parameters includes configuring the ST0 interface and binding to VPN, and configuring routes to remote networks that use ST0 interface as next hop. When configuring IKE, you must decide how you want to secure the Phase 2 negotiations, which is what the Phase 1 tunnel is used for. It is important to figure out ahead of time which of the cryptography options fit the level of security needed. The more secure options often come at the price of higher CPU usage. This is also something that should be discussed with the administrator of the peer device, since all of these options must match on both sides for the Phase 1 tunnel to successfully establish. When configuring Phase 2 IPsec options, you must decide how you want to secure the VPN traffic. Similar to the IKE options, it is important to figure out ahead of time which of the options fit the level of security needed. The more secure options often come at the price of more CPU cycles. This is also something that should be discussed with the administrator of the peer device, since all of these options must match on both sides for the Phase 2 tunnel to successfully establish. Administrators use the JOL VPN Wizard to configure site-to-site route-based VPNs. The wizard walks you through a series of screens that allow you to configure the necessary parameters. Running the VPN Wizard is not required to properly configure a site-to-site VPN, but it does make it easier than configuring the required parameters manually. The VPN Wizard creates the Phase 1 and Phase 2 configuration objects, tunnel interface, static route, and security policies necessary for a complete route-based VPN configuration. Once the VPN Wizard is finished, you can edit the created objects if necessary. In this case study, you learn how to use the JOL VPN Wizard to create a route-based site-to-site VPN on the branch office SRX series device. To complete the configuration and for the tunnel to be established, compatible configuration needs to be performed on the HQ SRX series device as well. From the JOL Configuration Mode workspace, navigate to Security Services IPsec VPN IKE Phase 1 in the menu. Click the Launch Wizard button. Ensure that the Site-to-Site VPN route-based option is selected. Then, click Start to begin VPN configuration. The VPN Wizard prompts for a user-defined name for the new VPN and information about local networks at the branch office. Specify the security zone and network addresses at the branch office that contain the resources that want to use the VPN. These values are used by the VPN Wizard to create security policies that allow traffic arriving at the branch office SRX series device to be placed into the VPN. Route-based VPNs require a logical unit to be created on a secure tunnel interface, or ST0. The logical unit on the ST0 interface is assigned to a security zone and bound to the Phase 2 VPN. A route to the HQ network will be created with the ST0 interface logical unit as the next hop. Select the zone for the ST0 logical interface. The forwarding lookup process on the SRX series device determines the interesting traffic destined to HQ in this example, to place in the VPN. Specify the branch office device's public interface and security zone, and click Next. The remote settings screen prompts for the IP address of the device on the other end of the tunnel, in this example, the IP address of the HQ firewall. Specify the IP subnets of the remote location that should be reachable through the VPN so the VPN Wizard can create the appropriate security policies. Then, click Next. This screen demonstrates how to configure the IKE Phase 1 and IPsec Phase 2 security settings. These values determine the encryption and hashing algorithms that will be proposed to appear during IKE negotiations and how the peers will authenticate. Select values that are supported by both peers. The VPN Wizard configures IKE for aggressive mode by default. If both peers have fixed IP addresses, main mode should be selected. During IKE negotiations, peers authenticate using a pre-shared key. Both devices must use the same pre-shared key value. Perfect forward secrecy, or PFS, is recommended for Phase 2 IPsec tunnel establishment so the keys used to encrypt and hash tunnel data are not based on the Phase 1 keys. Select the Diffie-Hellman group used by both peers to generate the Phase 2 keys. The Diffie-Hellman group setting must match on both peers. Then click Next. The Traffic Profiles screen determines the interesting application layer traffic that can be placed into the VPN tunnel. The VPN Wizard uses these parameters to create the necessary security policies to allow data to enter and exit the VPN. The default traffic is any. The Review and Commit screen displays the proposed VPN configuration that will be applied to the device. Click Back to return to previous screens or click Commit to apply the settings. The VPN Wizard creates the IKE Phase 1 and Phase 2 configuration using the settings you defined. You can create these objects manually without the use of VPN Wizard as well. The branch office device is now configured, but a compatible VPN configuration must be defined on the HQ device for the tunnel to establish. The VPN Wizard used the network and zone information you provided to create the required security policies to allow data to enter and exit the VPN. The Secure Tunnel interface is shown. The screen also displays the associated route used to forward data into the newly created VPN. Proxy IDs are created at the very beginning of VPN Phase 2 negotiations before protocol communication is established. Phase 1 uses a pre-shared key or digital certificate for peer endpoint identification, or PEI, whereas Phase 2 uses the Proxy ID for PEI. Essentially, Proxy IDs are used for one final check to verify the peer before IPsec tunnel establishment. If the Proxy IDs do not match, then the Phase 2 negotiations fail, and the IPsec tunnel does not establish. Proxy IDs are a way to identify the traffic traversing the VPN. Each peer device identifies a local and remote IP prefix plus a service, which must match on both devices. However, they do not enforce any type of rules on the forwarding of traffic over the VPN. The RFC for IKE defines how proxy IDs are formatted and what information they contain, but the RFC does not specify exactly how the proxy IDs should be derived. This has caused interoperability issues between vendors. When you create a route-based VPN, the Juno security device sets the proxy IDs to all zeros, 0.0.0.0/0. However, it is possible to overwrite these proxy IDs through configuration. You may need to explicitly define the proxy IDs for two common reasons: for an additional layer of security where both VPN endpoints need an additional authentication method before they establish the tunnel. To establish a VPN to non-Juniper devices, interesting traffic coming from the other side needs to match the proxy ID. When you create a route-based IPsec VPN tunnel, by default, the Juno security device sets the proxy IDs to all zeros, 0.0.0.0/0. You can override the default behavior by manually configuring the Phase 2 proxy IDs as shown. You need to configure both local and remote proxy ID values. The local proxy ID value must match the value of the VPN peer's remote proxy ID. The value you configure for the remote proxy ID must match the value of the VPN peer's local proxy ID. Traffic selectors provide an additional method for administrators to determine what interesting traffic is allowed to traverse a tunnel. While proxy IDs are only checked during IKE Phase 2 as an additional peer authentication step, traffic selectors are checked against transit traffic to ensure that only networks specified by the selectors are allowed to communicate through the tunnel. Multiple traffic selectors can be associated with the same VPN to allow for flexible administration. Traffic selectors in Junos support both IPv4 and IPv6 networks. However, there are several features that are not compatible with traffic selectors. These include proxy ID and point-to-multipoint or P2MP ST0 interfaces. The configuration for traffic selectors is shown here. In this example, the branch office and HQ devices have established a VPN tunnel through the untrust zone. The branch office and HQ devices each have two internal networks. However, only traffic for one network on each side is to be allowed through the tunnel. In this example, the branch office and HQ devices are configured to allow only traffic from the 10.10.101.0/24 network to the 10.10.201.0/24. Once you commit, you can also view the IPsec statistics that specify the number of transit packet bytes that the device has encrypted and decrypted. If all counters are 0, then traffic is not traversing the tunnel. Remember, a route-based IPsec VPN uses an ST0 tunnel interface. You can view whether the interface is up. If there is a problem in establishing the IPsec tunnel, the ST0 interface will not be in the up state. The traffic statistics for the ST0.0 tunnel interface demonstrating that traffic is being sent through the bound IPsec tunnel is also shown. Check the route table to verify that the next hop for IPsec VPN traffic is pointing to the ST0.x interface. Dead peer detection, or DPD, which operates securely over the IKE Phase 1 SA, is used to verify the current reachability and availability of the remote peer device. The DPD device sends an IKE "Are you there?" message to the peer, and the peer responds with an "Are you there?" ACK message to verify its availability. This process is repeated at a regular interval, 10 seconds by default, but the interval counter is reset anytime data traffic is received over the tunnel. VPN Monitor, which operates over the IKE Phase 2 SA, is a Juniper proprietary method for checking the health of a tunnel. The VPN Monitor process periodically sends Internet Control Message Protocol or ICMP requests to a configured remote address to verify reachability. By default, the peering address of the remote gateway is used, but this behavior can be modified through configuration so that the VPN Monitor pings a remote host behind the peer gateway. The optimized configuration setting causes the process to consider transit traffic through the tunnel as verification that the tunnel is operational. Welcome to the lab section. You have reached the end of this module. In this module, you learned to configure site-to-site IPsec VPNs, describe proxy IDs and traffic selectors, configure proxy IDs and traffic selectors, monitor site-to-site IPsec VPNs.